Welcome to another video on my Raspberry Pi 2 running Ubuntu Linux and using the robot operating system. The last few episodes I have tried to get signals working with a photonic transistor. I tested it previously using a robo interface. It worked all nicely, but the results using in this circuit were less than convincing. So I quit using that photonic transistor. Now another sensor from VisiTechnique is an LDR, light dependent resistor. And that means that the value of the resistance varies with light. May seem obvious, but anyway, that's how it works. The only thing is that the Raspberry Pi works digitally, and a resistor is by nature analog. So how do you do that? Well, you can only hope that the digital 1, which is above 1.5 volts for the normal GPIO, is being reached when you use this LDR. I haven't tried it yet, and I need to test it, and you already see some in and output. However, that was with a first recording and the recording went wrong. So I am once again going to see how this works. Now this is the LDR. Let me grab it nicely. So this is the LDR connected to the mains, 5 volts, and on the other hand, on the other side, let me say that, connected to the 5 to input 15. And now I have to reconnect this wire. So let me grab this. Not open enough. Alright. So when I now start the publisher and subscriber, what will happen? Right now, as you can see, the text is still saying light sensor. Well, strictly speaking, the LDR may function as a light sensor. Anyway, is this really working? Well, using this switch is not much use. Yes, it works, but what I primarily want to see is this changing anything? So right now it says a block. So there is nothing which says okay, I am over 1.5 volt. If I shine directly on it, it doesn't change either. So the idea is to take a multimeter and just measure the resistance over this LDR and see whatever happens. Oops, I mean this one. Alright, multimeter in place, set to measure resistance in ohms, and that goes to 200 ohms. So let's first put one of the probes to the plus. And then one of the probes to the minus. Now I have to be a bit careful how to put the probes. Alright. Then the other one, and I am in my own light, goes right here. And there is nothing, hardly anything to measure. Let me, this is better than in my own light right now. Now it's less. So I do see the needle moving. So right now there's a resistance of, let's say, 60, 80, I think 70 ohms. Yes, it has now a resistance of 70 ohms. The question is, if I dim the light, what will it be then? So I turn away the lighting. And it doesn't change at all. There's no change. I put back the lighting, measure again, and it says 70 ohms. So when there's light, 70 ohms. Alright, now the question is, how much can I measure the voltage? So I change the voltage setting to 30 volts and direct current. So I am measuring once again 0 volts. Then turn the light away, measure again 0 volts. So that is no use. No use at all. Can I measure something less? If I say do it like 3 volts maximum. Also nothing. If I put it to the lowest voltage, well then, okay, back to full light, lowest voltage measurement. The needle doesn't move at all. Now back to measuring resistance. 70 volts with light. So what does this mean? Unfortunately, that I have to find a way how I can measure, how I can change it to get a 3.3 volts if possible, because it is fed here by 5 volts. Oh wait, it's only logical to not measure over here. I have to ground it. Wait a minute, that's the whole thing, of course. So I have to change my type of measurement. Let's do that. So now the ground probe is connected to the ground. Now I am measuring on this side with the probe, because let's first measure here. That says no, I have to change this because I want to measure the voltage. So now it's voltage that I'm measuring, and right now I am measuring nothing. Yeah, because it is connected to ground. Now it is connected. Should be connected to the mains. Alright. Is it connected to the mains? No. And I have a wire broken. How can I change this quickly? Or can I change it quickly anyway? I have to do a live repair, I'm afraid, which is possible. I will use another wire for this. So I'm putting this into the mains. And fixing this into this one, into the LDR. Now I should have 5 volts on it. That is almost 5 volts. 4.5 maybe. So what is on the other side? On the green side, 4.5. That means with light it is actually the same. So I am turning the light away. What does it do? Absolutely nothing. That is weird. So within the without light, this is coming from the mains, this is going to the GPIO, but this has, they both have compared to the ground, 4.5 volts. Is this logical with the measured 70 ohms? Could be. Could very well be. So is there any other way to make sure that I can use this LDR to measure something? On the other hand, with 4.5 volts on the green connector, yeah, look here, it says pass. So the voltage is passed and it is a high, the input is high. So what if I turn the light away? Does it keep saying pass? Yes, it keeps saying pass. So is this a nice substitution for the photonic transistor? I can't quite say so yet. And this has no influence because this is much less light than the lamp I'm using. But it is high, that's something. But any other idea? Really have to think for its use. It would have been nice if I could actually use this whole setup as a model for analog input, but well, with a digital input only. Good question. I'm afraid the answer is as yet no. Let's see further. Alright, so far I am measuring voltage pass, which is kind of logical, but it's not the value. So I have refreshed my knowledge about electronics a little bit, and yes, of course, if you want the value of an analog component on a digital board, you need to have an ADC, an analog to digital converter. Unfortunately, I don't have one. Not that I can easily find anyway. So I cannot measure its resistance or any value of the resistor right now. Although I did measure its resistance, and that was 70 ohms as far as I can find. I have looked for some more data, and it shows that it can have resistance as high as several mega ohms, and when in the light it can have a resistance as few as a few hundred ohms. So the darker it is, the higher the resistance. So now let's measure it again. Going here. So putting everything, putting the meter back to ohms and measuring everything, and I should do it in a way that I don't obstruct camera and multimeter, or multimeter, which is hard enough this way. Let's try it this way. So I should do it like this. So right now the resistance is again 7 ohms, 70 ohms. Now they warn that in during time the working of an LDR is actually decreasing. The quality is gets lower and lower. So I am doing it different now. I am using kilo ohms. See whatever that gives. And that goes as low as 0.3 kilo ohms. So that's not 70 ohms, that is 300 ohm. So now it shows 300 ohms, and that is something quite different. Would it change if I totally cover the LDR? Yes, it has a completely different value. It would now be it is maximum of 1 kilo ohm, and you can't quite see it, I see on camera, so let me bring it a little bit closer. Now you can see the needle covering again completely, then measuring again. So this is where the needle is with kilo ohms, and this is uncovered, and this is covered. So this means it actually does work. And I have to measure it using kilo ohms and not ohms. So that's a big difference. The voltage is did not change somehow, but it should. So how to go on from here? Let me think. Yeah, I don't have an ADC, analog to digital converter, but once again, trying not to abstract. Oops. Yep. So let's see how to maybe solve this. Okay, so I've measured the resistance. I had to change from ohms to kilo ohms. That showed a huge difference, which indicated that the LDR is absolutely working. Now back to the results on screen with the light sensor, VPAS, well, light sensor, LDR, responding to light, so in that case, in that sense, it is still a light sensor. However, I have now gone back to measuring voltages, and as you can see, I have put the probe back here, connected to mass. So I am going to measure voltage again, and on a scale from 0 to 30, so it is on 4.5. Now I would expect, and yes, 4.5 is over the distance. Oh wait, that's a good one. Let me introduce then a resistor, because 4.5 volts might damage the 3.5 volt. That is a big ouch. So if I just say, I just realized that. So I have to do it slightly different. That is a very good insight. So what I need to do is have a different wire from the GPIO cable to the resistor. So here's a resistor now, from GPIO to resistor and from resistor to LDR. So how can I do that best? Taking this out. Putting it in on this side. Yes. And then I have to have a wire from here to pin 15. And that is a very good point. I don't have one ready at the moment. Let's see if I can scavenge something. And that is what you get with certain ideas. It may not always work like that. Not when you are recording something live. So right now I am trying to ready a cable which had something broken. Alright. Fixed this kind of cable. Plugging it in, or trying to anyway. And then trying to get it fixed into output 15, if I can manage that to happen. But considering the time, that is something for next time. So introducing today an LDR, trying to measure its resistance. Yes, it works. Kilo ohms, not ohms. Do I get a value? Yes, I do. Now it is uncoupled, so it says block, which is alright. It says 4.5 ohms, or 4.5 volts. Do I get that is way over the minimum of measuring 1 or 0. Delaying this repair with a resistor in it gives me the chance to find an ADC somewhere. So yeah, definitely going to be continued. So thank you for watching. If you like this video, please subscribe to my channel. If you don't want to subscribe for some reason, please follow me on Twitter and Instagram, or Instagram. If you like to make a small donation to keep this blog going, please see my website for more information, also for my other projects. Thank you very much indeed, and this is to be continued, obviously.